We want to talk about prime factorization. Before we can talk about prime factorization, though, there are a couple of vocabulary words that we want to discuss. First, and most obvious, would be the prime number. A prime number, by definition, is any number that is divisible by itself and 1. So, any number divisible by itself and 1. And before we list out some of the prime numbers, let's also jump into the next vocabulary word, which would be composite. A composite number is any number that has more factors than itself in 1. So, any number with, we would essentially say 3 or more factors. And so, if we talk about having prime numbers, the first prime number, a lot of times students want to say 1. 1 is not a prime number. 1 has a special name. It's a multiplicative identity that we discussed earlier in the year. So your first prime number is actually 2, and then 3, because as you look at these numbers, the factors of 2 are 1 and 2. The factors of 3 are 1 and 3. 4 is not, because the factors of 4 would be 1, 2, and 4. So that's the 3 or 4, or 3 or more factors. And so you can go 1, 3, 5 is a prime, 7 is a prime. Again, if you look at 2, 2 is the only even prime number you'll ever have. Everything else has to be an odd value. And then we go 11, 13, 17, 19, so on and so forth. It's really a good idea to look up your prime numbers. Have a list available to you. I don't have one. I expect you to go look them up. And so right here I have a list that I just printed off the internet. I looked up the first 25 prime numbers, threw it together, printed it off. Real simple. It's not a bad idea to have that at your disposal, especially if you don't remember what your prime numbers or are uncertain about what the prime numbers are. And then of course we have what we said, the composite numbers. That's any number with 3 or more factors. And so really what we do when we talk about prime factorization is you want to take a composite number and decompose it. You want to list out all the prime factors that make that number. Example for this method, let's start off with something like 18. 18 clearly is not a prime number because it's even, and we already said 2 is our only even prime number. On the internet I saw 20 different ways to do this. I don't like to do the factor trees. I think that's like an elementary idea. At the high school, I like to do this upside down division box and then just break it down. How you break it down is you list all of your prime numbers on the outside and you divide. So I'm going to start with my first prime number of 2. I divide by 2. 18 divided by 2 is 9. Now, again, another food for thought here, another supporting idea is I've told you guys to learn your squares. If I get to a square, I know that's a square value. I can simply go 3 times 3. Now your prime factorization is when you list all these factors out, no exponents. And so you go 2 times 3 times 3. That's considered a prime factorization of 18. And go ahead and just keep the camera rolling. We'll do another example of this. Let's say that I had 65. As I look at 65, I recognize that there's a factor I can bring out of there. 2 doesn't go into it. 3 doesn't go into it because if I do my rules for division, 6 plus 5 is 11, so that means 3 won't go into it. But 5 does go into it. And so I pull 5 out and I say 65 divided by 5 is 13. So the prime factorization here would be 5 times 13. And oftentimes as you go through these examples, you get better at them. So 80. If I want to prime factor 80, I can go 2 goes into 80 40 times, 2 goes into 40 20 times, 2 goes into 20 10 times. 2 goes into 10 5 times. All the numbers on the outside of these upside down division boxes are your prime factors. So once again, if I were to list this out, it would be 2 times 2 times 2 times 2 times 5. With a little practice, prime factorization is not difficult. We'll look at a couple of examples and then we're going to move into something called greatest common factor.